Well, we are just as fortunate to have a real rock star in the climate science world who's based right here in Indiana, named Dr. Gabe Filippelli. Gabe is a rock star in my view for a number of reasons. One is he is a rigorous climate scientist. He's written in such prestigious journals as Nature and Geology. He has chaired international expeditions to look at climate change by going way deep into the ocean, and he chairs a department here. He has a master's and PhD from the University of California, and he's a great speaker and a great communicator, and so he has this wonderful combination of just being a brilliant mind and a down-to-earth soul. So it's my honor to present our 2012 keynote speaker, Dr. Gabe Filippelli.
I have a title, The Politics of Ice. This is kind of a tongue-in-cheek title, with the assumption that climate change is a political issue. You'll see ice is neither Republican, Democrat, nor Libertarian, nor the Green Party. Ice is wonderfully unpolitical. When it's too warm, ice does one thing: it melts. It doesn't actually care about the elections. It melts during election year. It melts when there's no election years. Okay? If we look to the ice, we'll find a lot of answers to what the future will bring us. And with those answers, we can move forward from a state of knowledge rather than a state of fear. So I'm going to walk through some of the politics that I've encountered, provide a little climate change 101 lesson that many of you don't need, so I'll do it quickly, and then talk a little bit about climate change in Indiana. So if I were to take the temperature of the American populace over the last several decades, this is what I would see. What I would see is we've transitioned from the 1980s, when our instrumental record clearly showed that greenhouse gases, the concentration of these warming gases in the atmosphere has gone up. But is it warming? We don't know that yet. 1990s, okay, a lot of the temperature records show it is warming, but is it produced by humans? Who knows? By the 2000s, that decade, the last decade, okay, it's warming. People might be the cause, but there's still some kind of scientific controversy. There's still some kind of clash of the scientific titans. So we can't actually act till the 2010s, when I think it's become increasingly clear that it's not a clash of the titans. And it's not even David and Goliath, where all of us fat cat climate scientists are Goliath, and there's a few bright voices against climate change that David's out there. In fact, it is warming. Greenhouse gases are the cause. Humans are the cause of greenhouse gases. But you know what? Maybe it's too expensive to deal with. We've got other things to deal with. All of these last 3 decades, each one of them was warmer than the one before. And this year is certainly warmer than any other year we've ever faced in instrumental records. Then we come to the US elections cycle. Candy Crowley moderated the second presidential debate. Climate change. I had that question. All you climate change people. We just, again, we knew the economy was the main thing. And boy, climate change people? I think she means you guys. Okay? So she was speaking directly to you. Economy still main. Okay, first, climate change people. It implies an us against them, that there's people who are climate change people, and then there's the rest of the world. And economy is the main thing. The main thing of what? Maybe the main thing for voters, yeah, but what does she mean by the main thing? Well, no, maybe it is the main thing. This is Hurricane Sandy, a superstorm of unprecedented size. How much is it going to cost? Right? We don't know yet. I believe the latest estimates are edging on $1 trillion. I have colleagues in Lower Manhattan who still don't have gas and electricity. It's been a little while. And we are a first world country, I think. So maybe economy is the main thing. We have climate occurring, and a climate event, a weather event of unprecedented proportions, that is completely consistent with climate models. It's not, Hurricane Sandy was not caused 100% by climate change. However, Hurricane Sandy was most likely caused by climate change, if you get my drift. It's causing tremendous flooding. At the same time, we have the exact opposite in the southwestern U.S., which is also affecting the economy. This is the feedlot where you expect cows to be grazing. That's a tumbleweed. I haven't seen cows to be grazing. Cows to be drinking water, I'm sorry. And instead, the tumbleweeds belong to the feedlot. And we've seen our summer in Indiana. None of these things are inconsistent with climate change. In fact, they're exactly what we would expect from climate change. So what you hear when you talk about climate change is a bunch of things that make you afraid. You have Hurricane Sandy, you have unprecedented droughts, you have ocean acidification, coastal security, inter-nation strife. Well, all of these things have been cast in a palette, been painted in a palette of fear. And what I hope to show you through a lot of this is that palette that they've been painted in. Those terms fear, blame, and faith, and I don't mean faith as in faith-based communities, I mean a different kind of faith, are what is diverting national and local interest from dealing with a very simple problem that physics is going to teach us about, as we'll go through some physics lessons. Because we are thinking, what am I afraid of? How afraid am I? Who can I blame for this? Who can I blame for Hurricane Sandy? What do I believe in? Do I believe in climate change? Am I one of them? This conundrum is not unique to climate change. If you look at Thomas Kuhn's Principles of Scientific Paradigm, Scientific Revolution, you'll see that science goes through these things and public goes through these things all the time. Chemical structure, when we first discovered elements, people were really afraid back then when people were proposing the actual accurate definition of elements. Evolutionary theory and evolution, people are very afraid back then of how that would alter society. People are still a little afraid of it now. This is not held by scientists because, believe it or not, scientists don't believe in anything. Truly, our job as scientists is to cast doubt and attack any hypothesis that's put forward until we get the science right. Okay? And the science is never right because we find new things. That's our job. Our job is not to believe and come in here and say, I believe in climate change, I'm a believer. In fact, I know that all the climate change models out there are wrong now. I also know they're probably not grossly wrong. They're probably subtly wrong. Okay. So the best quote always comes from media. Movie Lost Skeleton of Cadavra, the worst movie ever filmed and produced in the nation. You can look it up. Ranger Brad says, oh say, you don't believe those old legends about the lost skeleton of Cadavra, do you? Dr. Fleming. Ranger Brad, I'm a scientist. I don't believe in anything. Okay? This is actually the crux of the problem. So what I'm going to try to explain now is how scientists go about studying nature. And I'm going to look first to physics. Maybe physics will provide us some kind of comfort into understanding how we get the nation and how we get Indiana to understand that science is not scary, that science is real, and what we've understood about climate change is what we've understood about climate change, which is quite a bit. We know enough to forecast 10, 20, 30 years in the future. So let's turn to physics. Thank goodness we have physics. So all fear should be allayed by knowledge. Simplest physics experiment in the world, which I can do in my lab. I don't think I can accommodate all you in my lab, so you have to go through shifts, but I can show you that I can have a sealed beaker with a thermometer in it, and I can put a greenhouse gas in, like, for example, carbon dioxide, shine a light on it, have a controlled beaker, sealed beaker with just air, And I can show you that the air inside the beaker with carbon dioxide is warmer, because the carbon dioxide captures heat energy before it releases back out of the bottle. The flask is a model for the Earth, right? It's the same thing. In this case, our stopper is outer space, well, effectively gravity, which keeps our atmosphere from flying off into outer space. So let me work through this experiment a little bit. If we do the same experiment on the planet, if we increase the amount of greenhouse gases, it'll get warmer. Ice doesn't lie. When it gets warmer, ice melts. When it gets warmer, actually, soil gets drier. When it gets warmer in cities, you have some problems with heat stress-related diseases and morbidity and mortality. But you know, there's a plus side. When it gets warmer, you could lose Arctic ice sheet. I know that's not a plus side for polar bears. I understand that, but it certainly is a plus side if you want to ship goods from China to Europe. It saves you half the time and half the cost if you do it over the Arctic Ocean. So warmer weather is also equal another plus side, which is lower fuel costs, lower fuel use. Warmer high latitudes also yield more crop potential. So what I want to show you is scientists, when they do the projections, they're not doing the projections based on fear. Scientists aren't trying to scare the populace into providing us with huge research grants. Trust me, the research grants aren't that big. If you saw the car I drove up in, I didn't get rich off of research grants. Actually, I didn't get rich at all, frankly. But there is a balance between the effects, the causes and effects. What I want to tell you is the cause of increased amounts of greenhouse gas in the atmosphere is warmer atmosphere, which means hotter temperatures, changes in precipitation, changes in ice, which makes for some positive and some negative economic and human effects. So with that simple outline of physics, why is there still a debate? The debate is because of the way we've passed the dialogue over the last 10 years. Scientists have not been actively engaged in communicating with good folk like you, communicating with people in state houses, communicating through the election process. We've allowed our own science to be hijacked with linguistic militarization. We've allowed the invocation of belief, not in its real form, faith-based belief, but rather belief in climate change or not belief in climate change. That's a real mistake. This isn't a war. ICE doesn't care. ICE doesn't care what you do in terms of your economy. ICE just melts when it gets too warm. This isn't a war also because, you know what? We're all smart enough to know that if the weather forecast calls for rain, you bring an umbrella, right? The weather forecast is calling for Hurricane Sandy's. The weather forecast is calling for higher sea levels. It's also calling for warmer weather in Canada, where you can grow more crops. It's calling for a loss of ice in the Arctic, and you can open up shipping lanes. It's calling for a lot of things. We just have to start listening and being smart, intelligent human beings and acting on some of this. So I'm going to give you a little climate change 101, and I can tell you, physicists abandoned us. They have not articulated the physics of climate change very well. So you know who it's left to? Schmucks like us, the geologists. We are there, we've got your back, and I'm going to go through a little bit of Geology 101, Climate Change 101, because you know what? We study climate change. Because almost the only thing left for us in the geologic record is records of extremes. We study times when the entire globe was iced over 650 million years ago. The entire globe was iced over. We also study times like when the dinosaurs roamed the Earth, when the entire planet had about 5 times the carbon dioxide it has now, and it was very warm, uncomfortably warm in then Indiana. Okay? So we study climate extremes, and the long and short of it is climate change happens, and it happens because of physics. We are altering atmospheric physics now, and guess what? Climate change is happening. No surprise. Let's do better at predicting it. We've studied ice packs, snowpacks a lot. Again, there are no packs behind snowpacks. Pun very much intended. Climate change 101. Let's deal with weather and climate first. Weather is what we feel right now. Climate is what we can expect to feel in the future. And the way that the American Association of State Climatologists have said it, climate is your playlist. Weather is the song you're playing right now. Okay? This is why we have a coat in Indiana in the winter. The Super Bowl, which was the most successful Super Bowl ever, in my opinion at least, did that prove that climate change is accelerating at unprecedented rates and that it's going to be 65 degrees every winter from now on? No, it didn't. But it's completely consistent with exactly what climate change predictions and now reality are showing us. We will get 65 degrees in February more and more often. And I've lived here for 17 years now. I haven't seen many winters where it doesn't break 0 degrees in the day. I remember, yeah, there aren't any more. That's why I haven't seen it. When I first got here, I thought, my God, this place is cold. I came from California. My God, this place is cold. It didn't get warmer than 8 degrees below zero. Well, I haven't seen 8 degrees below zero as a high for a decade and a half. Okay, so enough said. You guys are Hoosiers, so you know that. All of these climate events are really weather events. Hurricanes, droughts, melting ice, those are weather events, but they're completely consistent with what we see with climate change. And why is that? Because of this curve, the most powerful curve of science. This is the curve of science. Okay, scientists love squiggly line plots, and I'm not going to bore you too much with the ups and downs of the squiggles. But this is physics in your lifetime. We started measuring the atmospheric concentration of carbon dioxide since 1958, almost without fail. And this was what we found. First breath that I sucked in when I came screaming into this world in 1964 had a concentration of 320, 319 parts per million carbon dioxide. Carbon dioxide is a greenhouse gas, which means that it traps heat from escaping off of the Earth after it hits our planet. Just an added heat shield. Thank goodness for carbon dioxide, by the way, because we're too far away from the sun to have liquid water otherwise. We've always had a little bit of carbon dioxide in our atmosphere. That's a good thing. Too much too quickly starts becoming a headache for us. So anyway, too much too quickly, what do I mean by that? Well, my daughter's, your first breath, who was born in the year 2000 here? Nobody. I'm sorry. I stole this from a talk to a high school. But nevertheless, I'm sorry, no, I'm guessing your ages, but nevertheless, my daughter's first breath, she breathed in air that had 370 parts per million CO2, and we are breathing air that has 392 parts per million CO2 in this room. 392 parts per million is not going to kill you. We cannot put enough CO2 in the atmosphere anymore to kill anyone. But what it does is it increases the heat trapping capacity of our atmosphere. This change is in my lifetime. It's in your lifetime. We've changed atmospheric composition by 20% for this greenhouse gas. 23%. In our lifetimes. Before the year 1850, that number was not 320, like you see in the left-hand graph, but it was 280. So we've changed it quite a bit, and we've done that by combusting fossil fuels and cutting down forests. How does that relate? People say, oh, well, but climate change, CO2 is always varied. How does that relate to anything real? Well, you're right, CO2 has varied. And you know what? That variation causes climate change. This is the record from ice cores of climate change through the ice ages, which are marked by those low points in that curve, these curves, and non-ice ages, which are the high points of the curve. Every low point, we don't have much carbon dioxide in the atmosphere, and it's kind of cold. Every high point, we have a lot more carbon dioxide in the atmosphere, and it's kind of warm. You know why? Because of physics. Right now, though, it looks like we're beyond the variation, right? The natural variation for the last 6 million years, as long as we have a record for it at least, we have not had carbon dioxide concentrations above 300 parts per million. We are now at 390. And we're going up a lot higher, so I'll show you right toward the end. So this is not natural variation, people. Geologists know that it's not natural variation. You guys actually probably know it's not natural variation, but this is real. Okay? Let's go back on human timescales. There weren't many humans back in the last, actually there were in the last ice age, but not the one before. Human timescales, we can see that even over the early part of human history, this kind of civilized history, this is from the year 1000 to 2000. I'm not saying before 1000 wasn't civilized, but We didn't have much variation in carbon dioxide concentrations, that's carbon dioxide and methane, until the Industrial Revolution, when we started putting in quite a bit more carbon dioxide in the atmosphere. And you can see the squiggly line curve, then our temperature started going up. Physics. What does that mean for us on the ground? Well, it means global warming in a sense, but I'm sorry, I cannot stand the term global warming because it's not warming everywhere at the same rate. It is climate change. Nevertheless, whatever word you want to use for it, it's climate change, and it doesn't impact the planet consistently. In fact, as the models would predict, and as we're seeing play out, the high latitudes are getting warmer a lot faster than the low latitudes. It's largely because of the way heat can transfer on our planet from the low latitudes to the high latitudes. That's all well and good if you're Canada and you want to grow corn, maybe. In some provinces you weren't able to grow corn in. Unfortunately for coastal areas, high latitudes are where all the ice is kept on our planet. It's kept on either in glaciers and alpine glaciers or in the poles. And this disproportionate heating of the high latitudes causes disproportionate melting of these ice packs. This is from yesterday, the headline on NBC News. This is a science paper that explored the question, okay, we're having a lot of people saying that Antarctica and Greenland are not really melting very much, or they're not really contributing to sea level rise, that there must be some other factors too. So the melting of the ice sheet from Antarctica, the melting of the ice sheet from Greenland are not significantly contributing. Well, in fact, the group of scientists looked carefully at satellite images of both of those ice packs and sea level records, and this is from yesterday. Polar ice is melting a lot faster than we expected. And that is a cause of a little bit more accelerated concern about coastline stability. On the upper left is the Antarctic ice sheet, one big ice shelf that comes out of Antarctica. Hope you can see it. You might not see it. There's a crack in that ice sheet. That crack, cracks happen all the time in ice sheets, but that happens to be a huge chunk of ice. That's not sea ice, it's ice from Antarctica, which means that when it gets dumped in the ocean, sea level rises. On the squiggly line plot on the bottom is now our new projection of how much sea level rise is accounted for by Greenland and Antarctica melting. And what we're finding is contrary to what we've assumed for a while. Antarctica is melting and it is contributing to sea level rise. People thought it wasn't really before because it's pretty protected, at least for the short term. It doesn't appear to be that protected. Antarctica if that melts, it has potential to contribute quite a bit to sea level rise. So what's the impact of the sea level rise? Whenever you melt a glacier on land, you're taking fresh water and dumping it into the ocean. One impact is that you raise sea level. We've seen this, geologists have seen this through ice ages and so forth. What we're seeing is this melting that is consistent now across high and low latitudes. A little personal story. Upper left is a glacier in Tibet. I was doing field work in Tibet 3 years ago. I'm standing at the base of this mountain pass. The Chinese had just built a road that day over the pass. Unfortunately, we're stuck there because the asphalt hadn't dried yet. We hadn't been told this. And it's at 18,800 feet. And there's not much air up at 18,800 feet. And so it was a little uncomfortable. But that glacier is up there. And the only reason they built the road is because that glacier is 1,000 feet up the pass. 10 years ago, it was the pass. That glacier carved the pass. It's retreated so quickly and so consistently that the Chinese government knows that glacier ain't ever coming back. We're going to build a road over the pass to save a lot of travel time. Okay? I don't think we always, I won't politicize this too much, but I think sometimes it's expedient to have a communist party to tell you what to do. I love being in a democracy, however, where we get to discuss this. All right. So I would say that if you were to look at several of the key issues that we are going to face in our lifetime that are related to climate change, they are going to be sea level, and they're going to be temperature change and its impacts on agriculture. Sea level rise is inevitable. It's rising already. It's inevitable. It doesn't take much sea level rise. It takes probably, heck, this much to cause a hurricane like Sandy, a superstorm like Sandy, to sweep in about 10 kilometers farther inland than it would otherwise. Even if hurricane intensity does not increase across our globe, higher sea level means more coastal impact, because coastlines tend to be pretty flat. I think of Florida. And half of our nation's economy is on the coastlines. I mean, I think Indiana is a very important economy, but apparently New Yorkers, Floridians, and Californians don't think that. Sea level rise has a huge economic impact on our nation. We'll survive it, as will Europe, but we're not going to survive it easily, and we have to think of sea level rise as inevitable and start planning intelligently for it. For some countries, you know what, they've got no choice. I was a Peace Corps volunteer for 2 years on the island nation of Kiribati. It sits at sea level. It is its own sovereign nation. It has its own language, has its own culture. It's been there for 2,000 years, and by the year 2050, they won't have any drinking water left anymore, because their small amount of drinking water is stored underneath their, naturally by geological processes underneath their islands. That drinking water will become brackish. It already is. It's not rich enough to import water. They can't desalinize water. Doesn't matter, there's 16 islands, and there's one car on the island I was on. So it's not, they didn't contribute to climate change, by the way. That one car probably didn't contribute much to climate change. However, they're going to be the first recipients of the negative benefits of climate change, in this case, increased sea level. They already have bought land. They're leasing land in Australia and have a large tracts of land in Fiji. They're going to have to move out. And we found what happened when Native Americans in our country moved out from their native lands. You lose almost every one of those factors that make a nation a nation. You lose their culture, you lose their language, you lose their own livelihood, and you change the culture significantly. So let's talk a little bit about what we know happens to societies and cultures when you make some of these climate change shifts. My timekeeper. Oh, absolutely. You put a professor in front of the microphone, and trust me, you could be here all morning. But I know you actually have other things to do, so I'm just making sure you're not here all morning. So societies have been affected by climate change in the past. And one of the most valuable lessons we can take is how they have responded or not responded to climate change. The Mayan society is a great example of that. This is some of the work that I did with some colleagues that explored why the rapid demise of the classic Mayan culture. And anyone who's worried about 12, is that the date? Yeah. 12/1, thank you. I wasn't sure the exact date. Trust me, I'll still be sleeping soundly that night. So ends up they just misplaced one of the Mayan calendars, which extend much farther. But anyway, I digress. The Mayans went into a relatively rapid decline by most societal standards, and that decline was considered a product of warfare and overly religious society. Unfortunately, some egghead scientists have been studying this, and we find that probably the first driver of this was climate change. What happened was that the culture expanded significantly at a time when it was wet. And I don't know if you've been to the Yucatan Peninsula, it's very low. And they have these cenotes, these cave systems where the fresh water is pretty far down. It didn't used to be that far down when the Mayans were booming. And they were able to grow corn on their fields without irrigation. They waited for the rainfall to come. They got 2 crops of corn every year, something like that. They just waited for the rainfall to come and water the crops. And so they said, ooh, I like this crops. Let's build a lot more temples. Let's build a lot more. Let's increase population. And you know what? We need to have a lot more land, so let's cut down all this forest in the lowland and plant corn there. Voila, we have Indiana. We have Indiana. But the Mayans didn't have paleoclimatologists. They didn't have climate modelers. They had shamans. So their response was to sacrifice people. I'm hoping our response will be a little bit more proactive. Nevertheless, their society crumbled because, not just because of climate, not just because of war, but because of a ripple effect of not raining, not enough food. you know what, they depleted the soil resources because they weren't very good agronomists. Their water levels were down. Let's fight about this. Let's bring this into the realm of politics. In their case, it was religious politics, but politics. And then let's scatter off. You know, Mayans are still there, of course. They just scattered off and their society crumbled as a formal society. So, you know, I like to reflect on this as a lesson for the present. And then we just look again at the farmlands of Indiana, and you drive through Indiana and you see a couple of sprinkler systems. Very, very few. 3% of our corn is irrigated. I think maybe there's someone with a more accurate, a more recent estimate of that. But you know, when you depend on summer rainfall and it doesn't come, your corn crop doesn't do well. And your food source starts going away. It's not like, I mean, fortunately here it always rains a lot in the summer. Yeah, 30% loss of corn crops. Most corn fields complete loss. We spent a lot of time out in Montgomery County where you saw a lot of brown corn fields in July. In fact, they were already. I was wondering, when they were already harvested in August. Why is that? Well, they called it a loss and they cultivated everything in. It was 2012 weird. Probably not necessarily. It's probably 2013 summer might have more rainfall. I don't know. But it wasn't weird. It's about what we see now and what we project. This is Indiana's climate state in the winter and the summer going forward over the next 100 years or so. This is based on climate models that have now proven uncannily accurate. If anything, they've underestimated. In the winter, we become more like Virginia. Okay. Less ice, warmer winters, which means a lot less ice cap, which can be a problem. In the summers, we become more like Oklahoma, and I don't see non-irrigated cornfields in Oklahoma. I see livestock in Oklahoma. This is not voodoo. This isn't some fancy prognostication. These are the climate trends that are most likely we are going to see, and they have real implications for how we choose, how we handle policy issues locally. Because policy helps guide people and it helps guide agriculture to make right choices and help guide business to be intelligent. I'm not, Jesse and you guys are the policy experts, I'm not, I'm just a head scientist, but I know that they all work together, okay? Sound science can inform sound policy. Well, that was a model. Is it already happening? Yeah, it is. If you are a Burpee seed catalog buyer and you can't wait until February to think about what seeds you're going to buy or whether you do it yourself, I don't care. I only grow tomatoes and basil, but it's my Italian heritage apparently. But you know what? It's already changed. This is the plant hardiness zones. Hardiness zone has changed now from Indiana. The National Arbor Day Foundation has already reissued this because the reality is that Midwest, particularly Midwest winters are getting warmer. And that's because they are, and that's because of physics. What does that mean for us? Well, how warm will it get? There's a couple different projections. It could either get a little bit warm or a lot bit warm, depending on how we choose our own energy future. If it gets a little bit warm, you can see in the lighter colors, it would be a couple degrees warmer in the summer. I'm sorry. If it gets a lot bit warmer, it's going to get a lot of degrees warmer in the summer, which is a big issue, especially for public health. I also direct the Center for Urban Health at IUPUI. And we're concerned a lot about urban health quality and economic disparities, health disparities. And these are the projections on the upper right of where we will go in terms of days over 90 and days over 100, depending on these two scenarios. And you guys were here in July, I think, right? Yeah. I was. The big storm came and didn't deliver much rain, but took our power out for about 4 days. Coincident with 4 straight days of 95-degree weather. There was 26 days in the month of July that were greater than 90 degrees. We exceeded the number of hot days by far for quite a while. This is not unexpected. We're going to get more and more summers like this. So this is about advanced planning, about considering that. It's a big impact for health, not just for my cooling bill, and not just for an increased viability of geothermal heating and cooling, but for children's health. The incidences of asthma have increased substantially, even though in a lot of other environmental ways we've been doing a good job.
But a lot of these asthma impacts are because of higher temperatures. And a lot of them are also because of various particulate issues and maybe some other chemical factors we're not haven't nailed down yet. Regardless, cities will become less comfortable. Well, how sure are we that it's going to get worse? We're pretty sure. This upper, you know, you can think of climate modelers as, oh, that's a model. You made up a projection using math. I believe the last presidential election was predicted by math, too, but that's all right. These are the climate projections in the upper global, and then the bottom are just some global, some spatial averages, spatial projections. But see those climate bars? Those are in degrees Kelvin, my favorite thing. They're degrees centigrade over baseline. In the black line is what we've already experienced. The black line shows that within the purple bounds, we've already gone up a little bit, but these are the 180 models cross-tested against recent warming to give projections. That's the projection zone, the projection range. Yes, it will get worse. Kind of in the final bits, though, I just want to explain that we are not powerless. We are not waiting for things to happen to us. We have physics behind us. We have science behind us. We have sound science behind us. And we know what causes things to happen. I was born in 1964. My daughter was born in 2002. My great-granddaughter will be born in 2062. What world she's born into depends very much on what we do right now. I'm not getting emotional, I'm getting choked up with my dry mouth, sorry. Well, I wish I could get emotional on command like that. It depends very much on what we do right now. These are the climate projection scenarios of whether we very actively convert to cleaner energy resources, a host of which you are well familiar with, and I won't run down the list, but whether we very actively do that or whether we let things go and roll the dice and see how it turns out for us. The upper curve is how it turns out for us. It ends up that most climate modelers and paleoclimatologists say that the Earth is a substantially different place when we get above 3 degrees Fahrenheit over baseline. It's a substantially greater place because ice no longer has a capacity to protect itself from further warming, and it melts catastrophically. And it doesn't change. Once the ice melts, it's not like you can freeze it back up again. It's not what we call a sine curve of, oh, it melts and then you put in a little bit of action, it unmelts. It's a collapse, and it takes a lot of energy, in this case cold energy, to get ice packs back up again. When they melt, they melt. They take a long time to come back. Paleoclimatologists show you this, and the reality will show you this. So up above that range starts getting troublesome. Unfortunately, most of those projections are at that range, if not above. So this is what I mean about the immediacy, is don't fear this curve, but understand its immediacy, that we need to be at that lower curve by the time my great-grandchildren are born. We need to be at that lower curve if we want to control climate change in some way, rather than forcing it to control us in all ways. So I hope that I hope I haven't scared, my whole point is not to scare people. My point is that geologists have shown that the Earth goes through climate cycles. Physics shows us what it's going to be like. What we need to do is start using the science for our own good and not for evil. I just love, because scientists are often cast as these horrible, evil people. Except for geologists, they're usually saving people, which I like. So it's not that's not really the climate change debate anymore among scientists, at least, and maybe it is among other people, those non-climate change people, not among scientists. It's how much and how do we respond are the most important questions. So, and we're going to have to do two things. I am sorry, but we're going to have to do two things in our response. We're going to have to do the best we can to fight the warming world, fight against it. And I don't mean that in a militaristic way, I mean act against it. And there's a couple ways, there's one way to do it. Put up less carbon in the atmosphere. It's actually, fortunately, the physics, I can even understand this physics equation. Put up less carbon in the atmosphere, you reduce the rate of warming. That includes a number of actions that are both national policy issues, local policy issues, which you'll hear about, and personal choices. Having said that, our world is warming. Okay, I just want you to know it is warming. And it will continue to warm even if we stop burning fossil fuel tomorrow. Even if we stop burning it this morning. I wouldn't have had this projector lighting up because this is probably powered by the IPL Harding Street plant. But I don't know why University of Indiana, how they get their power array. But nevertheless, if we stop right now, it's still warm. You know why? There's a lot of excess carbon in the environment. It's in the oceans now, and it'll come back up out of the oceans. So no matter what we do, it will still continue to warm even if we shut down carbon emissions right now. The whole point of it is that, listen, we've got to be realistic too and look at what science is providing us. Don't be Mayans. If you can come up with one thing out of today, just think, I don't want to be a Mayan. Please don't let me be a Mayan. And we have to be intelligent about how we protect coastlines and plans for protecting coastlines. Yes, we can still protect low-lying coastal areas, but at what cost? And we need to be considering agricultural security, especially in a state like Indiana. We need to consider agricultural security here, and we need to consider water supply security, which I did not touch on. But I know we think we have a lot of water here in central Indiana. Yeah, we have a fair amount, but guess what? It's getting a lot poorer in quality, and it's probably going to get a little bit less plentiful in quantity as well. So we need to think along a lot of dimensions. We have to stop being afraid of climate, and we have to embrace it. We need to hug a geologist. And learn. I like that. Hug a geologist and learn from us. Not learn from us because it's all iterative process, but you just need to look to the science, and you need to form policy that makes sense and is realistic. Policy that makes sense climatically would be to stop burning all coal and everything tomorrow. That doesn't make sense realistically, but it probably does. It probably does make sense in our very near future, and that's exactly the kind of thing we need to be thinking about. So with that, I don't believe I've overrun my time.